that one's kind of got
Hey, what's up, fellas? Balancing some burners today using this here wind meter. We've got 6 burners and we have to adjust the airflow so that each one is getting about the same amount of airflow. We're working on the secret boiler today. And I'm just doing a customer update to show how far we've got thus far. This is the air manifold. I have to do a fuel manifold next, and each one of these burners is going to get a spark plug in there. So we've got 8 burners at 800,000 BTUs each. So we got quite a bit of power we're looking at right here. All right, fellas, that's done. Man, did that take forever. I had to pretty much draw out every one of these pieces on the computer. So that's why it took longer than I thought. I'm thinking it's because I had to design and draw all this stuff. It wasn't something you could just draw either. Like, I had to make certain points collide at the right transition point and all that. So it was a little bit more than just drawing it, but she is done. This burner is facing upwards, hitting on the bottom of that. This burner here is facing up in this direction, and the bottom here is going to glow red hot. Anyone who's ever been next to a campfire knows that the red hot coals, after the fire is burned down, is way hotter than the fire itself usually, unless it's a massive blaze. So the red hot radiant heat coming off this metal is going to be the strong point of this device. This is not a conventional burner system. This does not work like a conventional burner system. This is like putting a transmission on a 10,000 RPM engine. Imagine if you had a tractor geared down so low that it only did 3 miles an hour with 10,000 RPMs. If you hook the transmission up to it, you could make that same tractor do, 150 miles an hour. So that's kind of what we've done here, is we've built a thermal transmission that's going to convert a lot of the BTUs that are wasted in the air and turn it into infrared IR radiation. So a lot more energy will be captured in this area versus a bunch of hot air being thrown out the flue, because air has a very limited heat capacity, but thermal radiation is very powerful. Okay, for a quick recap, this is a liquid propane burner. So what you see there is me simply adjusting the airflow. We are not adjusting the fuel at any point in this test. And you can see when I turn up the air, this burner is burning all of that fuel in that tiny little space. So this is where the thermal transmission comes in. Now we're creating red hot metal, which is far more powerful than the thermal heat capacity of air. You can see there the liquid propane line vaporizing the propane. And we run liquid because you can't run this much power on gaseous propane. 60 PSIs won't push that much out of the bottle. Plus the bottle will freeze up on you with this power output. So as you can see, we are boiling a trash can of water at insane levels. It's kind of comical. And it doesn't appear to be a flame coming out of this thing at all. Now, a conventional burner would never be able to do this. You'd have flames shooting out of the side of that thing everywhere. So that is where the power of the Banjo burner comes in, is the thermal IR transmission. It doesn't have the same limitations. So don't let this deceive you. This is not the average burner. This ain't just going to have a little flame sticking out of the front of it. We're going to be burning about this much fuel out of each burner. The second most important attribute of this burner is the vast amount of air throughput involved. Because we have a blower and we're not using natural convection or aspiration, the thermal heat capacity of air is increased because we're pumping so much air through there in a given moment of time because we have the blower. So we're not actually increasing the thermal heat capacity of the air, but we are increasing the thermal capacity throughput because of the blower. So there's 2 special attributes to this burner that make it different than just a conventional burner with a blue flame propane type burner. They are just miles away in power. And I have some videos I did years ago testing the 2, where we used a jet burner. This thing right here, for example. This is a jet burner, and a equal size Banjo burner will outperform this thing so bad that I hung it up on the wall and it will never come down. I accidentally put one of my butterfly valves on the bottom there. I got a little carried away. No biggie though, we'll be able to get right out of that problem. See here, we have this burner here. It's facing down into this coil. So hot gases will be spraying out of these coils here. And then again, we get that hot, white hot surface, or in this case it'll be yellow hot, blasting the bottom of this coil with hot infrared radiation. At the same time, we have a burner facing straight down as well. So this thing's just gonna be getting pummeled with IR infrared radiation and with tremendous gas flow. So the next step is we have to balance these, and this is how we're gonna do that. Okay, so the next step is to balance these burners. And what I mean by that is each burner is gonna get a different airflow based on just basic fluid dynamics. So what we're gonna do is take this neat little meter here. This thing is so sensitive. I wanna show you this. So we have our blower on. We're gonna turn it up so that we get more accurate of a reading. I don't want this thing blasting necessarily at the moment. Okay, I think I've got 3 holes. Well, I will try the valve out to see if we get a reduction in action. And quite well indeed. So we're gonna just, okay, so that took about 15 minutes to balance these, because as I said, when you change one valve, you change the flow on every burner. It increases or decreases depending on what you do to this. So I had to walk through the whole thing several times and kind of dialed in. And as you can see, each valve has its own setting. One of them is, this one here was like completely off at one point, and it was still shooting out 2 meters a second. This bottom rail had to be completely opened. And these top ones all had to have some action. This one here, about this much of the valve is missing on the bottom. I do remember cutting that plate a little bit thin because it's not an off valve, it's just a baffle valve. I left it short. So I think that's why that valve's different than this one. It's just because I cut it short. But nonetheless, that step is done. The next step that has to be done is every one of these has to have its own spark plug, or else it won't fire up properly. We need an internal burn, not an external burn. So I'm gonna take this blower off and start routing fuel lines. And this phase is complete. So there you go, Bobo. I'm gonna send you an invoice on how far I've got thus far. Don't worry, in time you'll learn to love me again. This is where we're at. She's a beast. This thing ain't gonna be no joke.